Whenever you're asked to factor, there's a certain order in which you can go about doing things to make sure the factorization goes as smoothly as possible. Anytime you're asked to factor, the first thing you always should do is try to factor out a greatest common factor. As we've said before, if the polynomial has a greatest common factor, then pulling it out will either make the problem easier, or in some cases it'll make a almost impossible factorization possible. So that's always the first thing you want to look for. Now if you have 4 terms in your polynomial, then that is normally done using factoring by grouping. But if you only have 3 terms, then you're going to attempt that factor that polynomial into 2 binomials, and that's what we want to look at right now. Now the technique that I'm going to use basically amounts to a trial and error type technique. There are other techniques available, but we're going to use the trial and error because you can make some systematic, educated guesses, and usually that type of factorization, once you've practiced it enough, can be pretty quick. So let's just go ahead and jump into some examples of how this type of factorization is going to work. Let's start off with x squared plus 8x plus 15. Now all the factorizations that we're going to start with are going to have a 1 up front. In other words, a 1x squared, just so we can get a handle on the technique. Later on we'll take a look at how the factorization progresses as the coefficient goes from being 1 to being some other number. Alright? Now the main thing you need to remember with this factorization is that this trinomial is the result of 2 binomials. So we want to go ahead and jump straight to that assumption that this came from 2 binomials. And remember, when we multiply binomials, we use the FOIL method. So this will help us to remember where everything came from. For example, the x squared is a result of the first times the first, which means that in the first position here and in the first position here, the only thing we could possibly have is an x times an x. Now the 15 is a result of the last times the last, and there are several possibilities for that. Let's just try one of them. It could have been a 1 times a 15. And the next thing we need to figure out actually is not where the 8x came from, but the signs. And we can come over and we can summarize a rule for the way the signs work. If you have a plus plus in the trinomial you're trying to factor, that means that when you factor it, there's only one thing that could have happened with the signs. A plus on the end means the 2 signs had to be exactly the same. Now since they both added to give you a positive in the middle, this can only mean that they were both positive to begin with. So in other words, this plus plus means we can have nothing other than a plus plus right there. And that takes a little bit of the guesswork away. Now, the first is always easy to see whether you've got it or not. The last is always easy to see where you've got it or not as well. The question is always in the middle. Did we get the 8x? Alright, and we're going to check the outer product, and we're going to check the inner product. We're going to add them up, and we see that we didn't get it. So the 1 times 15 simply didn't work. So we're going to try another guess. How else could we have gotten a 15? Well, another way would be with a 3 times 5. 3 times 5 is actually a smarter first guess, because you should notice that 3 and 5 add to be 8. So when we check the inner and the outer product and add them together, we get our 8x. So that was a correct factorization. Alright, let's try another factorization somewhat like that one. Let's go with x squared plus 7x plus 12. Again, it is a trinomial that has to factor as two binomials. The x squared can only be an x and an x. Now let's go ahead and take care of our signs. Plus can only be plus. The 12 could be 1 and 12, 2 and 6, 4 and 3. What's the most reasonable guess? Well, since 4 and 3 add to be 7, that's a very reasonable guess. You could have guessed 3 and 4. Sometimes guessing them in a different order will make a difference. Sometimes it won't. The only thing you can do is try them both. Alright, so the x squared is correct. The 12 is correct. Let's check the middle. Here we've got a 4x. Here we've got a 3x. That adds to be 7x. And that's a correct answer. Alright, so let's try another example with the different sign patterns. Let's try an m square minus 6m plus 8. Here we have another different sign pattern. So we're going to factor this again as a binomial. And look at the sign pattern and see what this tells us. Our sign pattern is x squared minus bx plus c. And let's see if we can figure out what this would have to be. Since there's a plus on the end, the only way you can get a plus is with two pluses or two minuses. Now, since this is added to be negative, the only conclusion we can make is it was two minuses. Alright, so what we're kind of seeing with these two rules, if the sign on the end is a plus, the two signs have to be the same, and it will be the sign in the middle that tells you what they are. Alright, so we've concluded a minus. M squared can only be m and m. The 8 could be 8 and 1, 2 and 4. Which one is most reasonable? 2 and 4, because that adds to be 6. Now maybe it was 4 and 2. Let's check. Here's a negative 2m. Here's negative 4m altogether. That's a negative 6m. And that is it. That's the correct factorization. You can always check your answer simply by multiplying back out. Alright. One more example. Again, one that is relatively similar to that. Let's look at b squared minus 11b plus 18. Again, it has to factor into two binomials. The plus on the end means the two signs are the same. The minus in the middle means they were both minuses. B squared can only be b times b. Now 18 could be 18 times 1, 9 times 2, 6 times 3. Which one's the most reasonable? Well, let's say we were to try 6 and 3. Let's see what happens. Here's a negative 6b. Here's a negative 3b. Altogether, negative 9b. That doesn't get it, because that wasn't the most reasonable guess, was it? The more reasonable guess for an 18, since we need to add up to be 11, was a 9 and a 2. This gives me negative 9b. This gives me negative 2b. Altogether, negative 11b. That factorization has just checked. So that is the way it factored. Now notice that since I have a leading coefficient of 1 up here, that these guesses have actually been pretty easy to make. It is when the leading coefficient is something besides 1 when they become more difficult. And we'll get into that at a later date. For now, there's another sign pattern we need to see. If we had a x squared minus x minus 20, we see another sign pattern here. What we've seen is that the minus on the end isn't the same. We've had pluses all along. So let's see what that means when we have an x squared. And we're going to see if it doesn't matter if it's a plus or a minus bx. Minus on the end. Well, think about it. How do you multiply and get a negative number? The only way to do it is for one of each, a plus and a minus. The order won't matter, we'll find. Alright, plus, minus versus minus, plus. This won't tell you a distinct order. The order will matter, but the only way to find the correct order is through experimentation. So, order makes a difference, but you only know what the order is when you do some trial and error. Alright, x squared is x and x. We'll try plus and minus just to see how it goes. Alright, 20 could be 1 times 20, 2 times 10, 5 times 4. Now, since we're adding and subtracting, it would be reasonable to try the 5 and the 4. Not because they add and give you 9, because they could subtract to give you the 1. Alright, let's see what happens. We've got a 5x, a negative 4x. That adds is give us a positive 1x. And that's not what we were looking for. But it's extremely close. Realize that it is only off by a sign. So, we can come back, and what we will find is that the only thing that needs to be changed is the sign. If you swap the signs, then the constant in the middle just changes to become the opposite of what it originally was. So now we have the correct factorization. The x squared is correct, the negative 20 is correct, the negative 1x in the middle is again correct. Now let's just do a couple more examples of these type factorizations. Let's look at r squared plus a 14r plus a 48. Alright, and let's see what this has to factor down to. It is a trinomial. Plus plus always means plus plus by this rule up here. R squared has to be r times r. 48 could be 1 times 48. Could be 2 times 24. Which factorization of 48 should we use? Well, let's see. 1 times 48 would give us a 49. 2 times 24 would give us a 26. See, how else can you break down 48? What about a 6 times 8? Why is that a reasonable guess? Because a 6r and an 8r gives you a 14r. Alright? It's always the middle that tells us how we've done ultimately with our factorization. Now, one thing we haven't seen with these examples is a GCF. None of these have had a GCF. I haven't even mentioned pulling out a GCF. But GCFs can show up in these type of problems. If we had a 2a squared minus a 12a minus a 32, you notice that that actually has a GCF. And like we said, number one thing, factor out a GCF. We've been getting away with not doing it, but that doesn't happen very often. So we're going to have to take one step over. We see that our GCF is a 2, and I pull it out, leaving me with an a squared minus 6a minus 16. So what does the 2 do as far as our answer is concerned? It's going to come over and sit next to the 2 binomials. A squared has to be a times a. The minus on the end has to be a plus and a minus, or perhaps a minus and the plus. We'll figure out which it is. 16. Let's see, I wonder if it's, say, maybe 4 times 4. See, a 4a, a negative 4a, that's 0. No, that doesn't work. So 4 times 4 didn't get it. What are our other options? Let's see. 4 times 4, no. 16 times 1, no. That's going to be a big number. We don't need a big number. How about an 8 times 2? Let's see what happens. Here I've got an 8a. Here I've got a negative 2a. That gives me a positive 6a. Is that what we needed? No. But it's really close. How close? I think that the only thing I'm going to have to change is going to be the signs. Exchange plus minus for minus plus, and let's see what happens. A negative 8a along with a positive 2a, giving us a total of negative 6a. That's what we needed. So again, there's your correct factorization. Let's do one more where we have to pull out a GCF. Let's look at 2x cubed y minus 12x squared y plus 10xy. And let's see what we've got. Actually, I need to clean this up a little bit. This is supposed to be a 12x squared y. And let's see what kind of GCF we've got. We can pull out a 2. We can pull out an x. And we can also pull out a y. Let's take a look at what that leaves us. That leaves us an x squared minus 6x plus a 5. A 2xy just comes over into the answer. Here I've got to have two binomials. X squared's got to be x times x. The plus on the end could be two pluses. It could be two minuses. Since there's a minus in the end, two minuses is the way we're going to go. 5 has got to be a 5 times 1. Let's check it. Negative 5x, negative 1x, all together, negative 6x. That's correct. Alright. Now one more thing to show you. It is possible for more than one variable to show up in this type of problem. And that's really nothing to worry about. It really shouldn't be a problem for you. Let's look at x squared plus a 16xy minus a 17y squared. Alright? To keep up with a good habit, let's look for GCF, and there's nothing. So we've got straight to two binomials. The minus on the end has got to be a plus minus, or maybe it's a minus plus. We'll figure that out. The x squared is an x and an x. The 17 is bound to be a 17 times 1. But since I have this y squared on the end, it's going to be a 17y and a 1y. So in other words, y squared comes from y times y, just like x squared came from x times x. And let's check it. This is a 17, and let's go alphabetical here, xy. And right here is a negative 1, xy. Altogether a 16, xy, and you've got it. So that, again, is a correct factorization. Now, another thing to mention is it is entirely possible with these types of problems that you can run into something that is prime. All right, in other words, there are problems in which the factorization simply can't be done. All right, let's look at x squared plus a 7x plus a 5. There is no GCF, so I'll go straight to two binomials. The plus plus means it's got to be plus plus. The x squared has got to be x and x. And how many ways can you get a 5? Well, 5 and 1 is one way. 5x, 1x gives you a 6x. That didn't work. The only other way to get a 5, besides a 5 and a 1, is a 1 and a 5. But we again find this results in a 6x. So we would basically just come over and say, well, we tried. And once you try every possibility and find that none of them work, you can then conclude that your polynomial was in fact prime.